It's essentially using a quite a large simulated environment with various different setups, such as this one, for example, which is driving in the mountains, in the forests. There are also different cities or suburban environments, and the idea is we're able to collect lots of different data from the onboard sensors, such as the camera, the lidar. This is the depth camera, for example.
Okay.
So it will then go into a segmentation image, I believe. Yeah, so here you can see a segmented view, which you can use the ground truth data to already start building up the control algorithms without having to go through the whole process of accurate object detection or classification before being able to actually do something from the control side. And we're also able to get the lidar scans from the vehicle, which actually feeds into some of the quantum stuff that George is going to talk about afterwards. As well as that, we're able to get some more innovative sensors, such as the event-based cameras. So this looks pretty messy because it's still beginning stages of development in the simulation for the event-based camera. But the point is, there are lots of different sensors which we're able to utilize during the development. And this video is just showing the lidar scan with the object labels already attached to it. So for example, the road would be in pink, and then the other cars would be in blue. So we can already separate the cars to start looking at what we can do with the data to develop a prototype as quickly as possible. One of the things that we did as part of the project last year was to develop a one-to-one scale of the area around University College London. It includes exactly the same road layout and the street signage and kind of the traffic flow. So we would be able to test the control algorithms in a certain scenario, which we would come up with. And an idea behind that would be, for example, you could see a real driver performing and then an automated vehicle performing in exactly the same scenario, and that would give you the grounds to compare the two and see which one's better and how you can improve the automated solution. This is just quickly to show that you're able to collect the data in lots of different weather conditions. So for example, this sun flare may affect your camera object recognition capability. So you're able to test that before you actually move on to production on real hardware testing with real data. So you're able to save a lot of resources like so. And the plan is right now to create a prototype for the artificial recognition, so the course tuning aspect, which would then be pitched to OEMs and hopefully go into an ADAS solution before moving into fully automated control of the vehicle. And that's the course tuning solution. So figuring out whether, for example, it's safe to perform a lane change before performing a lane change, using the same logic that a real driver would use, is something that we're working on right now with another team of UCL students.
Yeah, because it's essentially a prediction that humans do at the moment, isn't it? Yeah.
Yes. So it's using that human intuition rather than what cars are doing right now, which is fully robotic. They don't have that almost instinct of what's right to do right now.
Yeah.
That's it for me.